infinity. So example, you have numbers. If you have a number, you can certainly think of a bigger number. You can think of a bigger number than that one, and a bigger, and a bigger, and an even bigger number. And we think of that as positive infinity. Likewise, if you have a number, there's also a smaller number, and a smaller, and a smaller, and a smaller number, and that we think of as negative infinity. Now, there are many kinds of infinities, and I'm here to talk about another kind which is completely different than positive or negative infinity. Think of a sheet of paper. So on this sheet of paper, you can draw any point you like, or you can also put a line which extends all the way up to your infinite expanse. Now, if you have any 2 points on this infinite sheet of paper, the interesting thing is that there's a line which contains these 2 points. But if you have 2 lines, most lines will have a point in common, but some lines won't. So for example, if you look at here, at this wood paneling, if you look at 2 vertical lines, they will never have a point in common. So we like symmetry. So I would really like that any 2 lines have a point in common. To do this, we bring points from beyond. We just add points from infinity to each of the lines, and we do this in a really clever way. By doing this now, we make sure that any 2 lines either have a point in common on the paper, or if they're parallel, they have a point in common outside. They have this point of infinity in common. But this is nice. The problem is that now we have points which don't have a line in common. These points are infinity. There's no line containing them because all the lines are still on my plane. And the way to solve this is now I add yet another line from beyond by adding the line at infinity. Now everything is fine in this geometrical system. Any 2 points have a line in common, and any 2 lines have a point in common. Why is this useful? So not only because of the symmetry, but now by doing this projective geometry, we can find all the solutions we need of a polynomial system. So no matter how many polynomial equations we have, this is one of the key components we need in order to find solutions. And if we look at other systems, we can, for example, find nice proposed networks, or we can even try to find good error correcting schemes, as in your digital TV, just by looking at beyond. Thank you.